Hello, my name is the Math Train, and today we're going to do applications of quadratic functions. A few pieces of what you'll need is the vertex formula, which is the x-coordinate of the vertex formula would be negative b over 2a, and then we substitute the x-coordinate of the vertex into the function given to get the y-coordinate of the vertex. We are taking what we learned and applying it to application questions. Another thing that you'll need to brush up on is completing the square. And let's begin. So, the height, h meters, of a springboard diver above the surface of the water, t seconds after she leaves the board, is given by h of t equals negative 4.9 t squared plus 8.8 t plus 3. So that's the function given, representing the diver above the surface of the water. And then our first question is, how high was the diving board? So we input t of 0 seconds with output of h meters. So we input 0 seconds into the function h of t, and that will give us the height of the diving board in meters. So we input 0 into h of t for the starting point, aka the height of the diving board. How high is the diving board? So we input 0 into h of t, and we get an output of height in meters. Okay, let's begin. So we input 0 into h of t, so it's negative 4.90 squared plus 8.80 multiplied by 0 plus 3. And then we have negative 4.90 to the power of 2 plus 8.80 multiplied by 0 plus 3. And then we cross out these two terms because multiplication by 0 is 0, so we cross out those terms, they cancel out. And then we have h of 0 seconds equals 3 meters. And then we have our little therefore statement. The height of the diving board is 3 meters. So there you go. So our next question is determine the diver's max height above the water. So we can do this in two ways. So we need to find the vertex. So you can use the vertex formula, aka this formula right here, and input into h of t equation for the x-coordinate of the vertex and the y-coordinate of the vertex. Or we can put standard form quadratic equation, and we complete the square. We have our h of t function, and so we have the vertex formula, and then we input the x-coordinate of the vertex into the function for h of t, or an output of the diver's max height. We have a little diagram here. So our x is time in t seconds, and then our height is in h meters. And what we need to find is the vertex to get the max height of the diver. So we start at 3 meters, and we need this, the max height of the diver. So I'm going to be doing this way, so we can complete this square with the standard form of a quadratic equation, or we can use the vertex formula, and then we input the x-coordinate of the vertex into h of t equation, and you end up getting the x-coordinate of the vertex and the y-coordinate of the vertex. So we're going to be doing it with the vertex formula, which is outlined down here, and then our function is outlined down there as well. Sorry. We have H. Oh, it's down there. So we have, this would be A, and this would be B. Okay, so we have Vx equals negative 8.8 over 2, negative 4.9. It's negative 8.8 over negative 9.8 equals, so the Vx would be 0.8979 seconds. So that's the x-coordinate of the vertex. And then we put in h of Vx into the function to get Vy. So we input the x-coordinate of the vertex into the function to get the y-coordinate of the vertex. So h 0.8979 into the function. So we just input into calculator. And then our answer would be 6.9570 meters. I believe. And there we will go, the maximum height of the diver is 6.9570 meters. And that's our therefore statement. Okay, so that question is done, and we're going to be going on to the next question. The height of a flare above the ground is a function of the time it is in the air. An equation representing the height of the flare, h meters above the release position after t seconds, is h of t equals negative 5t to the power of 2 plus 100t. And again, we have our input of t seconds and our output of h in meters. We have a diagram to represent the flare's position and how it gets shot into the sky and eventually returns down to the ground. We have time in t seconds, so that's x, that's our input, and then we have our output in h in meters of height. And then we have our vertex and our maximum height of the flare. So what is the height of the flare after 3 seconds? So we input t of 3 seconds into h of t, the function, to get an output of height of a flare. So we're going to do h of 3, -5, 3 to the power of 2 plus 100, and multiplied by 3. And then we input that into our calculator. And then we get h of 3 equals 255 meters. And then we have our therefore statement. The height of the flare after 3 seconds have passed is 255 meters. So it's pretty simple. We just input t equals 3 into the position function, and then we get a output of height of the flare. So we inputted t into these variables here. We inputted the value of 3, and then we inputted that into our calculator, and then we get an answer of 255 meters. And then we have our therefore statement. The height of the flare after 3 seconds, t equals 3 seconds, have passed is 255 meters. And that's our answer for that question. So, and then we have a question part B. What is the maximum height reached by the flare? So you can get this in 2 ways. You can complete the square to get the vertex, or you can use the vertex formula with standard form equation. So this is our vertex formula. We used it in the last question, and then we input the result of this equation, which is the x coordinate of the vertex, into h of t, our position function, for an output of the vy, which is basically the y coordinate of the vertex. So here's h of t, so we're going to be putting the result of this into the variable of t, and we will get an output of vy, the y coordinate of the vertex. Moving on. H of t equals -5 t squared plus 100 t. So this would be A, and this would be B. So we have Vx -100 over 2 -5 Vx -100 over -10. And then we have Vx equals we have Vx would be 10. And then we input into calculator or reduce. Okay, so we have the x coordinate of the vertex, which is 10. So t equals 10 seconds. And then we input b of x equals 10 into h of t to get vy. We have h of 10, negative 5, 10 to the power of 2, plus 100, multiplied by 10. H of 10. And then we get negative 500 plus 1,000. H of 10 would be 500 meters. So we have the vertex, which would be 10 and 500. So t would be 10 seconds, and h of t would be 500 meters. And we do a therefore statement. The maximum height reached by the flare is 500 meters after 10 seconds have passed. So that is our second question, and we are done with quadratic application questions, and I hope you found this very helpful. Thank you very much, and I'll see you in the next video.